Symmetry and skewness, with respect to the mean.
What happens when the mean and standard deviation change? So let's say the mean goes negative or gets lowered. You can see that the mean here now is here. Okay, it gets pulled to the right of the peak of the curve. Okay, so most of the data tends to the left, and we have the long tail on the right, and we'd call this right skewed, positively skewed. All right, so now look, what about standard deviation? Okay, let's leave the mean at 0, leave the picture kind of centered, and see what happens when our standard deviation gets higher and lower. Okay, so our standard deviation, as it gets bigger, you can see that our curve is a little shallower. Okay, our wave, so to speak, does not have as high a peak. In other words, a higher standard deviation, okay, let's leave it here. A higher standard deviation, the data is more dispersed, okay? So you have more of a little even flow here, okay? As your standard deviation gets lower, so does the dispersion. So more of the data is going to be piled up in the middle with the center, the measures of center, okay, like the mean. Incidentally, let me just remind you guys that for the normal distribution, the mean, the median, and the mode are all there in the center, and they're all going to be represented with the same number, okay? Now, when that changes, when the mean, median, and mode are going to not be equal, that's when we have skewed situations, okay? So let me check this out. Let's look at this. First, I have a picture of a symmetrical distribution. And it's a normal distribution, okay? If you ever do a bar curve and you see your data is in the center, mostly the peak of the data is in the center, and it subsides on both sides evenly, that can be considered normally distributed. Okay, it's typical symmetric distribution. I don't think we need to, I hope I don't need to define symmetry for you guys. Something symmetrical has the same area under the curve on both sides. It's balanced around the mean. Okay, so this is what a symmetrical distribution would look like. Okay. All right. So now let's look at positively skewed. Something positively skewed, the mean is typically going to be greater than the median. In other words, as it gets skewed, the mean pulls off to the right. Positively skewed. One way to think of it is, where is the long tail? Okay, the long tail is on the right. And also, let me just say this, that if you're going to have outliers with this, if you're going to have outliers in your data, then they would be there out in that long tail, possibly. If you would have to investigate if you have some abnormally high or abnormally low values that seem to be affecting your distribution. You need to investigate your measuring tool or just the measurements. It could be legitimate data. That's up to your discernment when you go to investigate that. So you can see here that the mean is greater than the median in the right skewed or positively skewed data. So negatively skewed now. Okay, it's just going to flip it around. Your long tail is on the left, and your mean is pulling off to the right of the median. So the mean is less than the median. Here's your long tail. If you're going to have outliers, there will be in that tail somewhere down, in the low end of your data. Okay, so that's kind of the skinny on the skewedness, and also what happens when your standard deviation changes. As it rises, it's not as steep. The standard deviation gets bigger, it's not as steep of a curve. And as it lowers, it gets really steep. So you do not need to sketch these normal distributions every time you're doing one of the problems. Get good at graphing just a simple bell curve and label it. You do not have to do like a perfect graph in our class of this. Not a technical graph anyway. Okay, I will talk to you guys soon, and let me know if you guys need help with anything. I'm around. You know how to get in touch with me. Talk to y'all soon.